All right, as we get started with our second semester, we're beginning a new chapter, and it's going to look kind of similar in a way to what we started the year doing with solving right triangles. Remember, where we would be given three things about the right triangle, usually an angle and a side, maybe a couple of sides, and we'd also be given the right angle. And we would use trig functions, we would use Pythagorean theorem, we'd use complementary acute angles, things like that to solve right triangles. And we used right triangles all last semester. But it was always right triangles. This semester, we're going to start out by looking at non-right triangles. So the next section in your notes, the first section for the semester, solving oblique triangles. You might remember this term from geometry last year. Oblique referring to not perpendicular or straight, so oblique triangles. Triangles without right angles or non-right triangles. Solving oblique triangles, solving non-right triangles. Well, first thing I want to take you back to is in geometry, we showed triangles, if I give you certain information, have to be exactly the same, size and shape. What's that term for triangles that are exact, or figures in general, exactly the same size and shape? Congruent, right? Congruent figures. And I showed you that if I knew a side, an angle, and then the very next side of a triangle was equal to the same side, angle, side of the other, the triangles had to be exactly the same. What we could say then is if I gave you two sides in the included angle, there is only one triangle you could possibly draw. So we could say that side, angle, side determines a triangle. Well, for that matter, any of my congruency methods for proving triangles congruent could be used to determine a triangle. For instance, our next method was angle, side, angle. If I gave you two angles and the side between them, it had to define a specific triangle. For that matter, side, side, side. I'll give you all three lengths. Now, assuming that the longest side is shorter than the sum of the other two, remember. You might want to jot that down. Long is smaller than sum of other. So as long as the longest side is smaller than the sum of the other two sides, we're good. But, given that, there's only one triangle you could draw or construct, right? We said side, angle was also a way. Given any side, any two angles, it doesn't have to be angle, then side, then angle. Given a side in any two angles, that had to define a specific triangle. But there was one method we said didn't prove triangles congruent. In fact, we tried to do a construction with it, and the first time we did it, it worked, and the second time we did it, it didn't even work. You couldn't even get a triangle out of it. It was side, side, angle. Remember? We said, ooh, that doesn't actually prove triangles congruent. But in some cases, it could define a triangle. It could define a couple triangles. So we're going to include this as a way of being given information about triangles. And if you're given information in these sets, specifically these first four, there is a singular triangle that you can solve everything about it. What I want to focus on for now are these two. The kind where you've got two angles. If you are given two angles, and again, one of them won't necessarily be a 90-degree angle. We won't necessarily have a right angle. But if you're given two angles and one side, we're going to solve not with Pythagorean theorem, not with sine, cosine, tangent, but with something called the law of sines. Now, if you're in physics, you already know about this. But I'm going to treat this as if maybe a student watching isn't taking physics or hasn't taken physics yet, maybe going to take it in the future. What is the law of sines? Well, I want you to consider for a moment any random triangle. Let's call the triangle ABC. Now we know if the vertices are capital A, capital B, capital C, the sides are lowercase a, lowercase b, lowercase c, correct? If I were to draw a perpendicular straight down from this vertex, do you remember what we call any line drawn perpendicular from one vertex to the opposite side?
Segment? No.
It's called an altitude of the triangle, remember. And we represent altitude with the letter H for height. You might remember that from your area formulas. If you forgot your area formulas, they're on the bulletin board back there. But you don't need those right now. But I want you to consider something. By drawing this altitude, I took what was a single triangle and I made it two smaller right triangles. So we're still coming back to right triangles in a way because that's everything we know is right triangles. Well, I want you to consider for a moment this angle A. If I knew the length of side B, and if I knew the length of the altitude, this is the opposite leg of this right triangle, and this is the hypotenuse of the right triangle, isn't it? So I could say that the sine of angle A equals opposite, the altitude, over hypotenuse, which is side B. I could do the same thing for angle B. I could say that the sine of angle B is opposite altitude over hypotenuse, which in this little triangle here is side A, correct? Now you'll notice that the altitude appears in both equations. If I were to solve for the altitude, I would cross multiply. Altitude equals B times the sine of angle A, and altitude equals A times the sine of angle B, correct? But we know this, that quantities that are equal to the same quantity, h, the altitude, are equal to each other. So that means that b times sine A is equal to a times sine B. And I could turn that into a proportion, because if the product of two quantities equals the product of two other quantities, sounds like geometry all over again, doesn't it? Then either pair of values may be used as the means, and the others as the extremes in a proportion. So I could make A and sine of angle B one of my extremes, and then B and sine of angle A could be my means. I could do the same thing by drawing another altitude, and I could use angles B and C and show the same thing. For sake of time, we won't. But we could finish it off by saying that the ratio of A to the sine of angle A equals the ratio of B to the sine of angle B equals the ratio of side C to the sine of angle C. If I lost you on the explanation, don't worry about it, okay? Unless you want to go back and rewatch it. What you need to know is that that is called the law of sines. Those of you in here all took physics. Do you remember this formula? A over the sine of A equals B over the sine of B equals C over the sine of B? All right. So it's a pretty easy formula to memorize because it's got a pattern to it. It's also a pretty easy formula, if you will, or law to use. Let me show you how we're going to use this. Write this information down. Suppose I told you that we have a particular triangle, and one of the angles, we'll call it angle B, is 42 degrees. Another angle, angle C, is 51 degrees, and then the side that would be side A is 4.8 inches. Notice you are given two angles, one side. That means it could be angle, side, angle, two angles, one side, or it could be side, angle, angle, two angles, one side. Really, truly, it doesn't matter which one. But, for reference sake, later it'll help you to kind of figure this out. Here's the deal. If these letters all mismatch, then that means this angle isn't across from either, therefore it must be between them. So if there are no matching letters, it's angle, side, angle. I'm going to jot that down. There's no matching letters, so it's angle, side, angle. But even if it were side, angle, angle, we're still going to solve using class the law of sines. Now I point this out because of what's coming in the future. You won't use the law of sines for all of these triangles. You'll use them for these ones. So it's good to identify what we're looking at. We're looking at angle, side, angle, therefore we're going to use the law of sines. So what I'll start with is just plug in the numbers. I'll set up my three ratios, and I'll say A, well that's 4.8 inches, over the sine of angle A, which I don't know, equals B, which I don't know, over the sine of 42 degrees, equals C, which I don't know, over the sine of 51 degrees. And you start by plugging in all the values you do know and leaving the values you don't know. Does that seem pretty easy? How do we begin? Step number one. Find the third angle. Pretty straightforward. You probably would have guessed that. You already know two of the angles, and I know already that all three angles, class, have to add up to 180, a straight angle, right? So if I've got 42 degrees, I've got 51 degrees. How many degrees does that leave for angle A? 87 degrees. And there's the first thing that I found. So as far as what I'm finding angle A, side B, and side C. Well, angle A, 87 degrees, one down. So we'll start find the third angle first. Number 2, solve two proportions. Step number 2, solve two proportions. Now I want to point out where these two proportions are. You'll notice that by this point, if I have all three angles and one side, then one of my three ratios is complete, correct? Two of the ratios are incomplete. So what I'm going to do is I'm going to pair complete ratio with incomplete ratio. That's going to be one proportion. Then I'm going to pair complete ratio with other incomplete ratio, and that's my other proportion. So my two proportions are 4.8 inches is to the sine of 87 as B is to the sine of 42. The other is 4.8 inches is to the sine of 87 as C is to the sine of 51. Make sense? Let's start with the yellow one, the one involving B. To solve a proportion, class, we start with the two things you know. That would be the extremes here, correct? The 4.8 times the sine of 42. Make sure your calculator's in degree mode, by the way. Wouldn't want it to be in radian mode here. That could really mess things up. And we'll do a 4.8 times the sine of 42. And how big is side B?
3.21 inches.
3.211, blah, blah, blah. Now, here what we're going to do is we're going to round all of our angles the same. 2 sig figs, 2 sig figs, 2 sig figs. And we're going to round all of our sides the same. 2 sig figs. So we're going to go 2 sig figs here for B. So how will I round it?
3.2 inches.
3.2 inches. And then we're going to solve the green proportion. Again, start with the two you know, which are the extremes again. 4.8 inches times the sine of 51 degrees.
3.7 inches.
And divide away the sine of 87. And it's still 3.735, blah, 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 rounded 3.7 inches. Easy enough to solve? Almost easier than solving right triangles, because it's a more consistent method. You're not going, sometimes it's Pythagorean theorem, sometimes it's sine, sometimes it's cosine, sometimes it's tangent. However, my third step is to check. And all you're checking for in pre-calculus is, do the answers make sense? Well, what's my biggest side, class? The 4.8 inches, the A. What's my biggest angle? Gotta be then. Angle A. Is big over big? All right, where's my smallest side?
B.
B. Should be little over little, is it?
Yes.
Yeah, and then medium over medium. Does that make sense? So as long as your answers make sense, we know we're good to go. There are my answers. You can write this in your notes as well. Round angles the same and round sides the same. Round angles the same and round sides the same. But always at least 2 sig figs. Round angles the same and sides the same, but always at least 2 sig figs in this class.
It's never that easy. There's something else you add.
Well, let's take a look at another one here. Let's suppose I gave you a triangle and I told you that one of the angles, call it angle A, is 13.4 degrees. Let's suppose I told you another angle, we'll call it angle B, is 107 degrees. And one of the sides, we'll call it side A, which is across then from angle A, is 19 feet. The first thing I noticed is, class, I was given two angles and one side, which means I'm going to use the law of sines. However, notice there's a match, isn't there? So since this is opposite or across from angle A, it's not angle side angle. It's side angle and then the opposite angle. But it doesn't really matter. And if it's side angle angle or angle side angle, we're still going to use the law of sines. Anytime there's two angles one side, you're always going to use the law of sines. So what I'll do is I'll write out the law of sines, but I'm too lazy to actually write A over the sine of A equals B over the sine of A equals C over sine of C. I'm going to plug in the stuff I know. Well, I already know A, so class, I'm going to write 19 feet. Or I just write 19. Over, I already know angle A, the sine of 13.4 degrees. I don't know side B, so I'll put a little b, but I do know angle B, so I'll write sine of 107 degrees. I don't know side C, nor do I know angle C yet. But I'm too lazy to write angle C just to fill it in, because I'm going to start by finding that third angle first. I'm going to find angle C, I'm going to find side B and side C. These are where my answers are going. Let's just get angle C right now.
59.6.
Sounds right, and it is. Now, do I use all three sig figs? Yes. 3, 3, 3, so I'm going to 59.6 degrees for angle C. I would use 59.6 regardless, but for my answer, I want to round to sig figs properly. Well, here, 3 is sig figs properly, so we're good to go. Or wait, is it? 180 minus 120.4. I guess technically sig figs would be cutting it off here. Anyway, that's getting into physics and sig figs subtraction rules. Hey, these all got 3 sig figs, just round the angles the same, okay? So rather than confusing the situation, just realize I didn't really go into all those detailed rules for pre-calculus. So let's keep it simple in pre-cal, shall we? 3 sig figs, 3 sig figs. Yeah, 3 sig figs. All right. Step number 2, I need to solve 2 proportions. Once again, it happens that my 2 proportions are here and here. At your seats, solve for side B. And what do we get?
78.4.
78.40, blah, blah, blah. But if I'm going to round the sides the same, the sides are only allowed to have 2 sig figs.
Oh, yeah.
So my sides, I'm going to round this and say 78 feet. All right, then solve for side C. And what do we get for side C? 70.71, blah, blah, blah. But again, rounded to 2 sig figs. 71 feet. I do want to address this for my YouTube audience in case there's a question. One of the big mistakes that I'll see students make is they'll multiply 19 times, and sometimes they'll forget about the sign. And they'll say 19 times 59.6. And then they'll divide out the 13.4 instead of dividing by the sine of 13.4. And so you end up getting something like 84.5, for instance, for side C. So don't forget about the sine. It's 19 times the sine of 59.6. And you divide out the sine of 13.4. That's a common mistake that students might make. Let's check and make sure it makes sense. What's my biggest side?
107. It's side B.
Side B. And my biggest angle should be angle B. Is big over big?
Yes.
Yes. What's my littlest side?
19 feet.
By a long shot, the 19. Okay, so it should have the littlest angle. Is that the littlest angle? Then it makes sense. As long as big is over big and little's over little, then medium has to be over medium. We're going to have to check it. If big goes with big, little with little, my answers make sense. I probably didn't screw up. Because again, if you screw up, the screw up is going to make big not stay over big. Okay, if you forgot the sign, for instance, well, then you're saying 84 is side C. Well, wait a second. How can that be bigger, right? So there's the kind of mistakes you'll typically make will mess it up so bad it doesn't even make sense. There is one more thing you could check, by the way. Is the biggest side still smaller than the other 2 added together?
Yes.
Yes, because add these together it gives you 90. That's smaller than the 90. So that's a third thing you could check to make sure the answer makes sense. Questions on how to solve oblique triangles involving either side angle or angle side angle, a case where you're given 2 angles, 1 side. All right, turn your textbooks then to page 162, I believe. Yes, and do numbers 1 and 3. Page 162, do numbers 1 and 3. Now And let's see how you do using the law of sines to solve these two oblique triangles. Just a few minutes to work, and then we'll go over them together. On number one, the first thing you had to find was angle A. How big was angle A, class? 115 degrees. However, 1 sig fig, 2 sig figs, I said we're always going to do at least 2. Now again, I don't know, either way you slice it, either the physics way or the pre-cal way. If I'm going 2 sig figs, then I'm going to have to round my angle A to be what? 120. But don't use 120 in your calculation. Use 115. It's just where we list our answers. We're going to round it to the 120 degrees. Does that make sense? All right, then we need to solve for side B or C. Doesn't really matter. Let's go with B, right? We'll cross multiply. Sine of 50 degrees times 5.6, and then divide away the sine of the 115 degrees to get what for side B? 4.7. Good. 4.733, blah, blah, blah. Rounds to, and notice they didn't give me a unit. I don't need to give them a unit. Make sense? How many got the 4.73 blah, blah, blah for side B? Excellent. And then for side C, we're going to take the 5.6 times the sine of 15 degrees and divide out the sine of 115 degrees to get what for side C?
1.6.
Anyone have the exact number?
1.599.
Almost exactly, then rounding 2 sig figs. 1.6. Okay. Is the biggest still smaller than the little two added together? Yes. Is the biggest side lined up with the biggest angle? And the smallest side with the smallest angle? Then everything checks out. Did we get these three answers for number one?
Forgot to do the 120. But
Other than rounding to the 120.
Yeah, we'll change size for everyone.
Just to figure out the rounding as well. Okay, questions on that? Let's take a look at number 3, where you were given that side A is 92.00. In other words, they want 4 sig figs for your sides. Angle A, they give you as 72 degrees, and angle B, they give you as 35 degrees. Okay, by the way, notice no matches. This is angle side angle. Notice here there is a match, meaning an opposite side. This is side angle. Doesn't really matter. You're going to use the law of sines either way. We solved for the missing angles C and then sides B and C again. Okay, so they always seem to complete our first ratio for us for some reason. They don't have to do it that way. They're just choosing to for no clear reason. All right, so we've got the sine of 72 degrees underneath a 92.00, sine of 35 degrees. And of course, the first thing we need is angle C, class.
73.
Comes out to 73 degrees. Did y'all get 73 degrees for angle C?
Yes, sir.
All right, now by the way, 72 and 73 are really close, right? So we should expect side C to be really close to 92, maybe just a tiny bit bigger, because the angle's a tiny bit bigger, right? What do we end up solving for when we cross multiply? 92 times the sine of 73, divide out the sine of 72. What do we get for side C?
92.51.
Good. I've got rounded 92.51. I don't have the exact value written down, but it does round to 92.51. Again, just a tiny bit bigger than the 92. Did y'all get the 92.51?
No, I did it wrong.
Okay, go ahead and redo it real quick. Let's make sure we're good to go on this then. If you did not get 92.51, redo it. Make sure we can get the 92.51 before we go ahead. This chapter really comes down to calculator usage. So I don't want to rush ahead if we're not good on the calculator. We got it now? All right, tell you what, recalculate. If you missed the 92.51, recalculate side B just to make sure we got it right. So I'll give you a moment to recalculate side B as well. If you get the same thing, it's probably a good sign. But go ahead and recalculate, like the GPS, when you're trying to drive through Lee County.
55.5 or 48.
And yes, I got 55.48 also. Did the rest of you get 55.48? And again, does it match? Well, biggest, a little bit bigger than this, a little bit bigger than that, right? And then smallest. And the two small ones add up to more, way more, than the big one. Okay, so everything checks out. Are we good to go on number 3? Do we feel like we understand what we're doing? All right, go ahead and finish out the odds then, 5 through 11. Go ahead and finish out 5 through 11, the odds. Now that we got the handle on this. Again, if you're struggling at home working on these, make sure your calculator's not in radian mode. That'd be the first thing to check. Make sure remembering to enter the sine of the angle, not the angle itself. As you finish, raise your hand, I'll come check your answers and let you go on to the next one. So as you finish 5, let me check it, and I'll send you on to 7. Once you finish that one, then go on. But I want to check these as you go to make sure you're getting them right. Obviously, I can't do that for you if you're watching on YouTube. Sorry, Ethan. But for the rest of you in here, obviously, I can check one at a time. Finish with 5? All right. And don't forget your degree symbols. And 2 sig figs would need a point at the end. So go ahead and add the little point and the degree symbol. Otherwise, good. All right, go on to 7. Sig figs are nasty on 7, just a forewarning. End up having to use some scientific notation in there. Ugh. Got them all? Good. And I'm not sure if you benefited from hearing me talking to Quentin at all, but got the sig figs and everything good. Are you finished with 5? Good. Don't forget the point at the, oh, you actually did have it there, 40, 70 point, good. And then got the angle, good. And of course you want to probably list the angle as well. Good. All right, so if you're watching, your answers should be angle B is 38 degrees. Side A is 70 point to get 2 sig figs, and side C is 48. If you didn't get those, maybe pause the video, reach out and get some help before you continue on. Everyone's working on 7 now. Chris finished with 7. But only 2 sig figs. It was technically 1 from 5 degrees, but we said at least 2, so I have to round that to 2 sig figs. Don't forget your degree symbol. And then your sides should only have 2 sig figs as well. So let's round both of those to 2 sig figs. So all the answers going to be in 2 sig figs here. So do the rounding real quick. Let me check your answers while he's fixing those. It looks like you maybe rewrote something.
Which one?
Right here, it looks like 22.
Oh yeah, that's good.
Okay. And just remember the 2 actually is written not as an exponent. The E means exponent, so we don't have to also write that as an exponent. Good and good. Excellent. All right, go on to number 9. Good, good, and don't forget your degree symbol. All right, you can go on to number 9. Go ahead and put the degree symbol real quick. Just on the angle. There you go. Good. And again, the key is doing it in class, practicing with that, so on the quiz and test you don't forget the degrees. Because if every time you discipline yourself to put the degree symbols round to sig figs, then on the test you'll remember the same thing and we'll get those valuable points. Good, good, and now careful here, 2 sig figs. We said technically 1, but we always do at least 2 in this class. So if we rounded 2 sig figs, it would be...
160.
There we go. All right, let me give the answers to our YouTube audience. Angle C is what you should have found first. It's 156, but rounding to 2 sig figs, again, angle A is only 1. We said we're going to do at least 2 on everything. We'll say 160 degrees for angle C. We'll use 156 though in the calculations, of course. Side B is 302 point whatever. But we can only have 2 sig figs, so we end up having to round it to 3.0 E2, or 3.0 times 10 squared for our length. And then side C was 378 point whatever. We're going to round to 2 sig figs and say 380 for side C. All right, everyone's working on 9 now, except Quentin might be done. Yes, yes, yes. Good, going to 11. 9. Good. Good. So that'll become good. Excellent. Going to 11 once you fixed that. Done with 11 also. Show off. All right. Just finishing up. I'll check your 11 real quick. Don't forget the degree symbol, but everything else is good. And good. Now right here, does the 4 round the 9 up? No, you might be tempted to say, well, the 7 rounds the 4, which now round, but no, you can't do the only look at the digit right before. 4 isn't quite big enough to round it, so we'll leave it at
9.
There we go. But good on the other one. All right, let me give you the answers to number 9. Should have first of all found angle A to be 25 degrees. Should have found side A to round to 49 when you're allowed the 2 sig figs because B is only 2. And then side C, we're going to round to 120 for our 2 significant figures. Good, you're going on to number 11. Interesting notation. It says A equals C equals 22 degrees. What does that mean in plain English?
They both equal 22.
Yeah, A is 22 and C is 22. They're both 22, which means if you have 2 equal angles, you're going to have 2 equal sides, which means what kind of triangle do we have?
Isosceles.
Isosceles triangle. Good. Good, good. And then here, because the 22 only has 2 sig figs, we're only going to have 2 here. So you were correct with the second one. Yep. Looks like Jamie's just about finished with that as well. Good. 2 sig figs, 2 sig figs. Now here the angle's also only 2 sig figs in the final answer. So let's round that to... There we go. All right, so should have found angle B, first of all, to be 136 degrees, but we'll round it to 140 degrees to maintain 2 sig figs. And then obviously you could solve for A and then also solve for C, but you already know they're going to be equal. So you might as well just solve for one of them. You're guaranteed to get the same thing for the other. And you can see how the math works on that in the law of sines, but 9.7 when you round to 2 sig figs should have been your answer for both side A and side C. All right, your homework this evening is to do page 162, numbers 2, 4, and 6. Page 162, numbers 2, 4, and 6, practicing a little bit more with our oblique triangles and the law of sines. Have a wonderful rest of your day, and when the bell rings, you'll be dismissed.